This is one example of L'Hopital's rule. So we want to find a limit as x approaches 4 from the right of 3 times x minus 4, all that raised to the x minus 4. So if we were just to plug in 4, if we just plug in 4, we get 0 raised to the 0 power, which does not tell us anything. That is an indeterminate form, and that is not going to help us at all. So we have to go a different way to find the limit of this. Alright, so a couple of things. First of all, when you see your variable up there in the exponent and you're trying to do limits or something, then immediately you should start thinking about the fact that you're going to have to use some natural logs. So I'm going to let y be that entire expression, the limit, as x approaches 4 from the right of 3 times x minus 4, all that raised to the x minus 4. So first thing we're going to do, get that x minus 4 out of the exponent. We're going to take the natural log of both sides. So to get the natural log of y is the natural log of this entire expression here, the natural log of the limit as x approaches 4 from the right of 3 times x minus 4, all that raised to the x minus 4. Alright, now, I have properties of limits that I can use, of composition and different things when it involves limits. So I can rewrite this as, so the natural log of y on the left-hand side equal to the limit as x approaches 4 from the right of the natural log of 3 times x minus 4, all that raised to the x minus 4. It's a property of limits that you have, that the limit of the natural log of the limit is the limit of the natural log. It's a property that you can use with limits. Okay, so I get the natural log of y is equal to the limit as x approaches 4 from the right of x minus 4 times the natural log of 3 times x minus 4. Now, that helps me quite a bit to get that variable expression out of the exponent there. Now, I still have to make it fit something that's L'Hopital's rule. So, if I'm looking at the limit as x approaches 4 from the right, well, if I'm looking at the limit as x approaches 4 from the right, this limit here is 0 times the limit as x approaches 4 from the right of the natural log of 3 times x minus 4. That's just a shift and a stretching or shrinking of the natural log of x. So if you think about the natural log of x, as you approach 0 from the right, it goes to negative infinity. Well, this one's just been shifted over 4 units. So this is 0 times negative infinity, which is not something that I can use L'Hopital's rule on. It's got to be an indeterminate form that is either 0 over 0 or some form of infinity over infinity. So I'm going to have to rewrite this before I can actually use L'Hopital's rule. So I'm close, but I'm not there yet. So this is the natural log of y is equal to the limit as x approaches 4 from the right. I'm going to keep the natural log of 3 times x minus 4 up in the numerator. And I'm going to rewrite x minus 4 down in the denominator. So I'm going to rewrite it as 1 over x minus 4. Which is just a little fancy trick, I guess, if you want to think of it. Not real fancy, but it's just a trick you can use to get it to something that you can deal with. Because now, as I approach 4 from the right, my numerator is negative infinity. Let's try and do this in a different color out here. Is negative infinity. And my denominator, 1 over x minus 4. 1 over x minus 4, as you approach 4 from the right of 1 over x minus 4. Think about 1 over x is basically the same idea, but again, shifted 4 to the right, but we're at 4, so same premise. That is infinity. That is a form for which I can apply L'Hopital's rule. So here I go applying L'Hopital's rule. So natural log of y is equal to the limit as x approaches 4 from the right. If I use L'Hopital's rule, take the derivative of the numerator, take the derivative of the denominator. The derivative of my numerator is going to end up being just 1 over x minus 4. Take the derivative of the natural log of 3 times x minus 4. You get u primed over u. And so your 3's cancel and you're left with just 1 over x minus 4. Take the derivative of your denominator, which is 1 over x minus 4. You get negative 1 over x minus 4 squared. And that was my first application of L'Hopital. Everything else was rewriting and getting it to a form where I could actually use L'Hopital's rule. And now once I have it to a form where I can use L'Hopital's rule, I applied it that one time. So I have that the natural log of y is equal to, I'm going to rewrite this, the limit as x approaches 4 from the right. This is 1 over x minus 4 in the numerator times, flip up that denominator, and that becomes the negative of x minus 4 squared, all that over 1. Again, that was just a rewrite for me. And that turns into the natural log of y is equal to the limit as x approaches 4 from the right of the negative of x minus 4. Alright, now I'm home free. I have the natural log of y is equal to, take the limit as x approaches 4 from the right or the left, it really doesn't matter. I'm just approaching from the right, but that was because of my original problem. But now I have no problem just directly substituting in 4. If I directly substitute in 4, I get 0. So I get that the natural log of y is equal to 0. Now I'm still trying to solve for y. So I'm still not done. I still have to go back and figure out what y was to begin with. So if I use properties of logarithms and rewrite this, this says that y is equal to e to the 0, and that says that y is equal to 1. So there is my answer. If I go back up here where I started, I let y be the limit as x approaches 4 from the right of 3 times x minus 4, that raised to the x minus 4, and I found that that limit is 1 by doing all my work there. So again, just to kind of recap everything there. I couldn't use direct substitution because that gave me an indeterminate form that I could do nothing with. So I let y be that limit, and then since I had my variable in the exponent, that is key for you to know that you're going to have to use logarithms to get that out of the exponent. So that's what I did, took the natural log of both sides, and then you have that the limit of the natural log is the natural log of the limit. So I limit of the natural log, and I rewrote that as the natural log of the limit, and then I did some rewriting with logarithms, and then when I got to this line right here, I did still had an indeterminate form. I had 0 times negative infinity. But that is not a form that you can use for L'Hopital's rule. So you have to make sure you rewrite and to get it to a form where you can use L'Hopital's rule. Don't just use L'Hopital whenever you feel like it. It has to fit a form. It has to be an indeterminate form of a certain type. And one certain type that you can use is you can use some form of infinity over infinity, which I have. And now I can apply L'Hopital's rule, which means I took the derivative of each one of those, numerator, denominator respectively, and then did some simplifying, and that gave me a nice value of 0. But I wasn't done because I had to solve for actual problem that I began with, which is what I called y, and so I end up with my final answer there of 1. So I hope that illustrates some techniques you have to use sometimes with natural logs when you're doing L'Hopital's rule, and the fact that you have to make sure you get it to a certain form before you apply L'Hopital's rule. Otherwise, you're going to make mistakes all over the place doing limits with L'Hopital.